those other things unless otherwise, because I know that it's rare for someone to go for that in the exam. Okay, so right away, let's start with this question here. This one, it says find this. Okay, so this is the integral of x cubed, open bracket, x cubed plus 2x and plus 3 in close bracket x. So when they tell us that, what are they simply telling us to do? Is there anybody with a short with just a short phrase that they know they're asking us to do? I wish I loaded my.
Continue. There is someone who's asking for the link.
There's somebody who's asking for the link. Okay. You can share it with them. Are you able to share it?
No, because for these other groups, I'm using a different phone which does not have what to.
Oh, those groups, they have permanent ones. Those ones you don't have to share. So here, I can't drop it on WhatsApp because here, for me to start loading WhatsApp here, it will take time. So what I'll do is I'll just come here. I'll just drop it in the Zoti discussion group. Okay. I'll drop it in Zoti discussion group, then you get it from there, okay? I think I've dropped it. So you can get it from Zoti discussion group and share it on WhatsApp. Have you seen it?
Sir, but it's straightforward. If someone just opens Telegram, it's showing there on top. There's a live class.
Not everyone can do that. Even last time I said so. You understand? We are different. You get the point.
Where did you find it?
Zoti discussion group. It's a discussion group under this channel. Okay. When you just go to anything, you just try maybe to comment it to direct you there. Okay. So anyone in Zoti discussion group, or you can just search anywhere Zoti discussion group. It's a public group. It will come. Okay, it's a group under this same channel. So when you just navigate on top of the channel, there's why it's written discussion. Then when you go, you enter in that group. So the link is there. So you can. So have you done that so that we proceed?
Oh, I've seen the group.
You've sent? You've seen it?
I've seen the group, but I can't see the link.
Come again?
I can't see any link here.
Okay, listen. You are on Telegram, right? So I've copied the link. I think I can say, have you ever texted me on Telegram or something so that I can be able to send it to your inbox direct? Because I can't drop it in here in the channel because we are not allowed to do so. Okay, I want. Let me just look for you so that I can just these issues of my links. Once we announce this class, those people we've been putting links to this channel, so they are delaying us. You understand? Sometimes. Okay, so you can check your inbox. I have a message now.
I think. Oh yeah, I've seen.
You've seen it, right? Okay, so we can now proceed. So the one sending the link, just be sharp.
Has sent the link.
Somebody sent it. Okay. Okay, which is good. All right, so what they are simply telling us here is I'll use this same diagram as a reference diagram, but is it okay? Yeah, but you people, under cubic functions, we usually have maybe a curve, right? Let's just do this. Sometimes we usually have maybe a curve, okay? Yeah. No, the response is not good here. Okay, so let me just draw something roughly here. I don't know if it's the network or what. I don't know. Okay, let's see. Let's hope everything goes well. If you have, I'll just draw using freehand. Otherwise, I'll not be able to draw straight things. Here, I'm having a bit of difficulties. But looking at time, if you have, I want to explain that thing, okay? So you may have something like, a cave. Have you seen that cave? Maybe sometimes it's even emerging from this region of the X region. And have you seen this? So this cave, it has gotten a function that defining it, okay? Are you getting the point? So you find that there's a function. Now let's assume that's the function, okay? And you are told to calculate the area bound maybe by that cave, maybe on certain points, okay? Maybe that area that I've shaded, this one here. So that is what they are simply telling us. They're simply telling us to find the area, in short. That is what we are finding. Though they don't specify, but that is, I've told you the secret of the thing, what they are actually asking us to do here. So they're simply telling us just calculate the area there. That is why in paper 2, there's that question that comes under the same cubic function where they tell you to find the area. You can use integration just to help you solve that question with easy, and you use this, you calculate using those numbers by dividing maybe that region into smaller shapes of maybe triangles and rectangles, or maybe possibly squares. But what you have to know is that at the end of it all, you can use the same function to determine whether you are close to the answer. So if you find that your answer is far away from what you are finding using the calculation, you have to recalculate, which means that you made a mistake somewhere. So that's a hack, you understand? So it's a hack, in short. It's a mathematics hack, something you can use just to be sure to say, is what I'm doing right or wrong? You get the point. So the thing is, we have to find the integral of that, okay? Are you guys getting the point? So in this case, so you have to observe here. For you to know what to find exactly. I know why I'm explaining slowly and I'm taking my time. I know why I'm doing so. It's because some of you, calculus is something that you really find difficult to do it. You understand? So now, after this integral, do you have questions just come like this, okay? But you ask yourself, you look at the question, do you have the upper bound and the lower bound? If the question is yes, or the question is no. So if the question is yes, you proceed now. Sometimes you may find that of the upper bound, there's a number. Okay, the upper bound is bigger than the lower bound. So there's a number that is usually on top on top of this integral sign. So you'll find that maybe there's a 2, and maybe down here there can be a 0, 1, or maybe some negative numbers, okay? But those ones, they must be above that number. So you find, if you then you integrate and then proceed to the actual area, okay? So, but in this case, we don't have those numbers there. So now, what is it that we are going to do, okay? So that is where the question is coming from. Anybody with an idea here before I proceed to solving the question? Anybody with an idea? Anyone? Let's go, guys. Okay, so the first step that we are going to do is we are going to differentiate with x, since it's in this case, okay? Because this is the same thing whereby they can tell us to say, find, if you don't have those numbers, okay? If they tell you to find the integral of this, if you don't have the number on top and the other one down there, the first thing that you are going to do is, the first step is, we are going to integrate the sum term by term, okay? I'm sure this method that I'm going to show you is not the only one that you can use to solve this problem, okay? Are you understanding, guys?
Yes, we are.
So the thing is, okay, you know, maybe some of you who are not really familiar with the calculus thing may really find it somehow cumbersome, just walking you through some processes. But maybe let me teach you a similar way of integrating this, because this is just 2 marks you're fighting for. So if I tell you factor out the constant in each, if I say let's integrate the sum term by term, okay, which in this case we are going to have the integral of. So if you find this confusing, you tell me, okay? I'm saying we first integrate the sum, okay, term by term. So how many terms do we have there? We've got x squared, 2x, and 3x, okay? We integrate the sum, okay? By doing so, we are going to get something like, where can I write? Because I'm really having a hard time here. I don't know why. But let's go. Let's go. Let's see what will happen. Hopefully things get better, because this whiteboard is really misbehaving. I don't know why. And I'm sure you guys can see that I'm having a hard time. But things don't just it's not always that things are like this. It will get better. Okay, so that's the first step. So if you've got a pen, that side, hopefully you have started answering. Okay, so the first thing is you can integrate the sum of each term, okay, term by term. So you do that so that you can verify with what I'm going to show you here, so that just to be sure to say, okay, what you found was it right, or if you are not right somewhere, you just correct that. Okay, so the first thing, let me just find where to write. I don't know why these things are not spelling. Okay, if we integrate the sum, listen, integrate the sum term by term. That is the first thing, okay? So integrating the sum, not like that, but let's do this. The integral, okay, of the first term, that is x cubed, okay? Then dx, okay, plus 2x, we add dx, okay, again plus, okay, plus the last term is what? Is 3, okay? 3, then dx, okay? So we split them like that, okay? The next thing, we are going to factor out the constant in each term, okay? We factor out the constant in each term. How? The first one, it will just be the integral of x like that, dx, okay, plus 2, okay? Then like that, then x dx. We are factoring out. So we factored out this one. Have you seen? So on the first one, it's a 1, so we cannot show it there. So we have factored out that. Then again, on the other side, plus the integral of the integral of okay, so on this one we don't have a constant, we just have, it's just a constant like the way it is 3x, so it will just be here, so it will be 3 dx like that, because it never, it wasn't, it didn't have a variable like that, you understand? So the next thing is, after factoring out the constant in each of the terms, now since you guys get me properly, I'll show you maybe a short way, but it's important to understand this process, okay? That's calculus for you, but don't take it complicated, but I'll also show you the other way, okay? So now, since the integral of x raised to the power k, of which that's a constant, like maybe in that case we had that cubed, okay? Delta x, okay, is equivalent to x k plus 1, okay, over k plus 1, okay? For what? When k, if k is not equal to -1, okay? That is a condition, okay? K should not be equal to -1. That's the thing. So now, we are going to now replace, okay, get me clearly, we need to replace the integral of this x cubed dx with, we replace it with what? Replace it with x to the power 4 over 4. Have you seen where that one is coming from? Because in the first term, if you saw, it was x raised to the power 3. Now, since that 3 is standing for a k, we now just say 3 plus 1, okay? So we are, since there's a 3 again here, we are going to say 3 plus 1, which is making a 4. That's why it's now coming. We are replacing this one with this. Are you guys understanding this process? I'll show you a short one, but it's important you understand it. Are you understanding so far? Are you guys understanding? Hello? You guys are now quiet. You don't want to, you are confused. Or what?
Yes,
You don't want to respond. Are you understanding? Where are other people? Okay. Let's see. let's proceed. This is calculus for you, so I don't want to really be fast in terms of my explanations. What is happening? Okay. So now, this is what I was just trying to explain. So now, if we can rub everything and just go the short way, like here I've shown you this one, you can do the same on the second term, you can do the same on the third term. So now, in short, everything that we have been doing, to simplify everything, is supposed to be like this. Let me now show you. Okay, it was just important. I just wanted to bring out this point for some reason. These points for some reasons, because it's important that students are supposed to know such information, because they're supposed to be understanding where some things are coming from, but okay, so I've left that visible there. So if we just pick it like that, let's pick it. We have been taught to find the integral of, we've got x is cubed plus 2x plus 3, okay, then dx. So going to do is the integral of these things. What you are just going to do is, since like everything, so it will just be x 3 plus 1 over 3 plus 1, okay. Then on the other side, plus 2x 1 plus 1 there, because there's an invisible one, there's no power, so we assume we just say there's 1 there, okay, and then over 1 plus 1, right? Are you getting that point? So now plus 3. So now this 3, it will just have an x. We just add an x to it, okay? So now the final answer will be x raised to the power 4 over what? X raised to the power 4 over 4, okay, plus 2, no? Because there will be a 2 down here, so it will just be x squared, okay? X squared plus 3x plus 3x. This is our final answer. Understood? Just it's the opposite of differentiation. So if we differentiate this, we must get that. Have you understood?
Good. Yes.
Okay. But how we find
question.
Yes.
Where have you taken the 2 there on 2x? So that's 1 there on top.
This one?
Yes, on
This
the
one?
middle.
Yes. Very good question. Since we are bringing whatever is on top down here, dividing, okay? 1 plus 1, it's a 2, right? The 2 will cancel with a 2. Have you seen?
Okay.
And we just have this one, that plus that, to give us this. You've now understood, right?
Okay.
Understood? All right, so let's proceed to the other. So I want you guys to take a screenshot of the next question as I explain some basics, because I said since you guys didn't submit your work, you're supposed to go and solve this question on top of those other questions I gave you. This one, you're supposed to solve this one under transformation. You go and research if you don't know about it, but this is a question. In the following diagram, triangle ABC is mapped onto triangle DEF by a single transformation, which is M. Now describe fully the transformation. So in your description, you should mention what type of transformation is this one. Is it rotation? Is it translation? Is it reflection? Okay. And you also mentioned how has it been transformed. If it's reflection, you mentioned the mirror line. Okay. If it's rotation, you mentioned the center. You find the center of rotation and the angle of rotation. Okay. Are you getting the point? If it's translation, you find the translation vector. You calculate that. So you mentioned, so this has been mapped onto that by what? By a translation with a translation vector, you put it there. Or this has been mapped into that by reflection through this mirror line. Let's say the mirror line is that, you understand. So you can find, you do a bit of research on that. It's not difficult, and then you answer this question. But I can give you a look. How is this? You just look at this one, because you have to look at the corresponding points. How are they, and how is the shape? Because this one thing you can tell here, this is not reflection. Because if it was reflection, it would have just appeared something like, maybe something like this, because it has just reflected the other side. Maybe if the mirror line is somewhere here, let me make it so clear. Maybe because I mean there are 1, 2, 3. Then if you make the mirror line this one, then it will start from there. Okay. So let me now. So if that is the mirror line, so if it is reflection, it will just be like this, because this one will be the mirror line. So it looks exact, but in the opposite direction. Like yourself, you're looking in the mirror, so it has been reflected on the other side. So that is the transformation. So we have removed the reflection from there, because you can just say it's reflection on the mirror line, which is in this case, it may be this. It can be reflected this side, but if it is this side, it will look like this. It will look like how? It will look like it, like that, then like that, and maybe like that. You see? So it can also be reflected on top, anywhere, but the reflection, it looks exact, but the opposite, the sides are corresponding. You understand? Like if it has been reflected along this one, if it's a mirror line, it will start from here. This point will correspond to that point, and just like that. Hopefully you guys are understanding. So this is transformation for you. It's a must know. You must know the translation, rotation. The other ones, shear, enlargement, the other components in the stretch. It's okay, you cannot know about them, but yeah, it's okay because they are optional, okay, in paper 2. But this one, you just have to know this one for the sake of your fighting for your 2 marks here, okay? So this one, yeah, you analyze it, but I've left it for you to know, is it translation? Is it rotation? Has this rotated, or it has just been, translated? But let me explain something about translation. Translation, if this has been translated, it goes in a straight line, okay? It goes in a straight line, and like if it went like this, it will also go like that, then down here. So if it has been translated, so in short, let me just tell you that this object was rotated. So I've given you that calculate. So go and find the center of rotation now at what angle, okay? Go. Translation, it will go, let's say if it has been translated down, it will not change the direction, but it may be just the same like that, like this. Let me show you, like that, maybe like that. You see, you've seen. So it has been translated, like it goes in a straight line, but sometimes it may move in 2 directions. It goes this side and that side, but doesn't change the shape. So if it goes maybe somewhere there, it will go like that, and it will be like that. You understand? But it will just be, to not change, to not be. So that's a thing. So how we find the translation vector? We just count how in which direction has it moved in a positive direction towards the x-axis, and how has it moved in terms of x, in terms of y. You see? So that is the translation. So we start with the x, then y we just put. Sometimes it may be 2, maybe 3, meaning that it moved along this side 2 steps, then it moved up along Y again 3 steps. So as easy as that, and translation is the easiest, followed by reflection. Then rotation is one that is a bit hard, and that's the one that you have to deal with there. And from there it becomes your homework, and you're gonna continue from there. And now let's now do this. We continue solving. So you guys are supposed to submit this work by tomorrow before 23 hours. So hopefully you have taken the screenshot. Have you taken a screenshot? Has someone taken a screenshot of this? Have you taken a screenshot? You have to take a screenshot so that you can put in the group.
Yes.
So tell your friends submission due dates tomorrow. After tomorrow, 23 hours, I will not mark anyone. So that's
Okay.
Yeah. Now let's continue. We did these other questions. Yeah. So if you missed the last lesson, there's a video in the channel. It's a very small video to download. You just need 150 MBs to download it. It's 1 hour 30 minutes. Times time you go through, right? Okay, so can someone help me with these questions? Oh, people don't want to come. How many people are there? It's okay, there's one person. There's one person. There are 2. Okay. It's okay. This is very nice and interesting. Anna, can you read for us the question? You are not reading. We need to interact. Class is supposed to be interactive. So that I see that people are paying attention.
I'm viewing it. Can you view it a bit? I can see it properly. Thank you. The diagram below shows 3 points P, Q, and R on level ground. Bearing of Q from P is 100. The bearing of R from Q is 150, and PQ is equal to QR.
Okay. Just a correction. Here, when you're reading mathematics, don't say comma, okay? Just say the diagram shows 3. And I heard you say below. Where did you get it?
Oh!
You are used to reading like that, right? Okay, it's fine. So 3 points P, Q, and R. So you just read it like that. You just have a pause, okay? Don't, yeah. You get the point.
Okay.
So this is our diagram here, as you can see, and find angle QPR, QP and R. This is a very easy angle to find, right? So what we are going to do there is we are going to consider the concept of, when they have told us to say the two things that will help us find the value of that angle are the two. Only we'll just use two concepts. PQ is equals to QR, and sometimes they may not tell you, but there is this, right? There are these ones that are just showing that the distance from here to there is equal to the distance from here to there. Okay, so now if these points they are of equal distances are emerging from this point, the Q, which is common in this one, meaning that the two side angles, like this one and the other one, they are equal. All right, are you getting that point? Okay, so now what we are going to do here, I also don't know the answer. We are going to solve it together, and we are going to prove, to say, is what we have found, is it correct? So the first thing that we are going to do is, sometimes the way it is with bearings, we want to find the angle at angle what angle specifically? Let's identify it. Angle QPR. Angle QPR is equal to angle QRP. Are you guys agreeing? Are you agreeing to that mathematical fact? To say angle QPR is equal to angle QRP. Are you agreeing to that? So now we just extend this line here like that, okay, to make it 180, and we can find the value of this angle, okay? And from this side, we just extend again another one like that, okay? And now we can find the value of this whole angle here, okay? Which other possible angle is, which other angle can you possibly find? Now, which other angle? So if we subtract this from 180, what is the value of this angle? This one.
30.
It's 30, right? Okay. So this one,
Yeah.
This one is 30. So you first try to find the angles that you can find, okay? Since you found that one as 30, we can also make a true north of R here and find another 30 here, right? Are you agreeing that this one is also 30? Because it makes a Z angle like that if we make it a true north here, okay? Like that. So this one is also 30. You've seen that? So now are you agreeing that this angle which is outside here is equal to that angle which is inside here? Are you agreeing? This angle which is here is equal to this angle which is inside here. The only thing that we have to find, we don't know whether this one is a 90 degrees. We don't know. So we cannot put a 90 degrees there because we've not been given that information. Okay? That's how funny these ones are. Okay? So, yeah, so bearing of that. Okay. So that is the thing. So now, which other angle can we find here? If you guys are able to see, we found this one is a straight line 180, and when we extend it, we found a 30, which is making an alternate angle of 30 again here. Okay. Which other angle are we able to find?
Angle, I think none can, from, was it P and the Q, they are
Which one?
180. it is a straight line. So it is add up 180. You can divide 104 from 180.
No. Do you know the reason why I'm saying no? Is because we've not been given any information that is telling us to say this one is a straight line. This one, you see, unless they told us to say P is due west or maybe Q is due east of P. You understand? When they use that language, just know that it's a straight line and you can put a 90 degrees there. Okay, so bearings are very simple, guys. This is one of the simplest topics that are found in mathematics, but you have to just analyze properly. So I want you guys to think before I tell you. Okay, let's go. Let's go. Okay. Let's do this, huh? This angle, this 100 that we've been given here. Are you seeing it? This one. Guys, this 100 which is here. This 100 there is let's try to use this theory, because here we are working with theories, okay? Because everything we are doing here must have a mathematical theory that we are using as to why we are saying what we are saying, okay? If you've got so we will not spend a lot of time. If we've got a triangle like this, okay, and there's a line maybe which is going straight like that. This angle which is here, this angle which is there, it's equal to the two opposite inside angles. So this one and that other one, they must give you that. So is there anything that we are seeing that may satisfy that condition here? Yes or no? This angle is equal to the two inside opposite angles. Is there anything here? Yes or no? I want you guys to see. Look at the diagram. There is no 90 degrees. There is no what, but the only thing that we have to find is find one of the angles which are inside here. Then one of the angles which are inside here. Then that's all. Okay? That's all. But again, look at this. This is true north, right? This is true north. And this is also true north. Are you seeing this? So this angle is equal to this angle. Are you agreeing? This is a straight line. You know, bearings, I would tell some people someday some hacks about bearings. You can do them in real time, whereby in real life you get your geometric instruments and you start constructing using the same theories that you are taught, okay? Okay, so guys, let's go together. This angle is equal to this angle. This is also 100. Are you agreeing with that? This one is a true north. Are you seeing this? So these angles are alternating, okay? This one with this, it's alternating. Equally, this angle is equal to this whole angle here. They're alternating because of the true norths that you have put here. Have you seen that? Are you guys agreeing to that? Let's hope you are there and
Exactly.
you are able to follow properly. Okay. So the fact that this one is 100 and plus that 100 plus that 30, what are we getting?
130.
130. Now we are going to say 180, okay, minus what? Minus 100 plus 30. You can show it, but I'll just say minus 130, okay? Are you getting the point? Minus 130. Minus 130 degrees. Okay, so which is giving us what?
50.
It's giving us a 50. And a 50, we are going to divide it by 2, right? To find each of the two angles. These ones, because they are same, okay? So now the value of the two angles is 50. So we divide it by 2 to find 25. And that's the value of these two angles. 25, 25. And we found all the angles. So now we can now go back and answer the questions, right? Okay. Have you guys understood properly? Or maybe you're still behind. So angle QPR. QPR is what? QPR, this one. 25, right? 25 here, right? 25. And the bearing of P from Q, P from R, okay? Sorry, just a minute. So now we need to find the bearing of P from R. No. When they tell you, they've said P from R. Okay? What I usually tell my students is that when they tell you P from R, just circle the last word, that has been mentioned, R, and you go to that one, R. Draw its true north. Okay? Draw its true north. So let's draw its true north. We've drawn that true north. Let's label it N. Okay? And now, from that true north, the other one that has been mentioned in the first place is what? Is P. Look at the line that is coming from P, because they said P from what? From R. Okay? We are going to P, but we are coming from R. So we should draw a line from the true north of that R. Now it should meet the line that is coming from P. That is how we deal with that one. And just like that. And you need to find the value of this. Okay? Have you guys understood? So now we found we had 30 here, right? 30 there. We had 30. And we had 25 here. So now, since we have those angles, we can now subtract them from 360, add the 2, and subtract them from 360. So let's say the answer here, the bearing of P from R will be equal to what? 360, okay, 360 minus 30 plus 25, okay, which is equals to what? You can calculate. You guys do the calculation. 30 plus 25, that's 55, right? Yeah. So 360 minus 55. What's 360 minus 55? 305? 305? That's the one. I'm just calculating from my head. Is it?
Yes.
It's a one, right? Okay. About that. And we only have a few minutes. We're not hit our target anyways. There are not a lot of people here, so I'm disappointed in you guys, but it's fine. Others, I'm sure they depend in, they're like, I don't know, I watch the video. But being here, being able to follow properly, there's a difference. Me, I don't watch the, I can't tell, though yes, I do go through the videos from time to time, but I can't tell, like, you guys, how big is the difference of being here during a live class and watching the video? How big is the difference? Which one is better? Maybe watching the video is better than being here, right? But we should just start making the. Yeah?
Being in class, you concentrate and like watching the video because you'll be having some other things to do instead of you just concentrating on watching.
I guess other people, they also have their own say that may be against what you have said. Maybe, but I agree with you. And that is why I usually mostly for the times just focus on live videos, because I personally have made a lot of live videos than tutorials, just videos. I don't even find it entertaining because I'm there talking to myself, imagining I'm talking to someone. Why am I talking? All right, so you guys, we move. Let's see. Are you able to see? Are you able to see this clear?
Wait a bit, I can't see it clearly.
You can't see? Okay.
Zoom it. You can zoom it.
Can't see the words. Only that.
Okay, so let's do this. So now you can see.
Yes.
Okay. So someone to read the question for us.
In the diagram, BCE is a right-angled triangle in which BC is equal to 4 centimeters and CE is equal to 3 centimeters. BE is produced to D.
Okay. So now they are telling us to say find the value of cos CED. Cos CED. Okay. Cos CED. So hopefully you guys are familiar with SOHCAHTOA, right? You're familiar with SOHCAHTOA? SOHCAHTOA. Okay, not Tao. SOHCAHTOA. I wanted to write SOHCAHTOA. Okay, so it's SOHCAHTOA. Like this. So SOHCAHTOA.
So, there's no egg on it.
Come again.
Course it has adjacent over at hypotenuse, but you have just put the course is adjacent.
So okay.
Is
Here.
equal to adjacent. Yes.
Okay. Yeah. So This one is just how can we call it? What term is it? A mnemonic, or we can call it a mnemonic. Yeah, it's a mnemonic. Or let me say something that can help you remember like how to go about such questions. Yeah. So now it tells you when to use sine. Okay. So sine, you need to say the opposite of a certain angle over the hypotenuse. Okay. And now when you have cos, it simply helps you to use as you need the adjacent over the hypotenuse. And now when you have tan, you need to know that you need the opposite over the adjacent for you to be able to perform your calculations and find whatever you are looking for. Is it the value of something or what? So this is how this guy works here. Okay, so here we go. And now we are being told to find CED. CED, okay? So, talking of CED, here we have to find the value of CEB, and then the negative of that will be the value of CED. Are you guys getting it? So now let's go back to the question. It's saying in the diagram, BCE is a right-angled triangle in which BC is equals to 4 centimeters and CE is equals to 3 centimeters. This one, they are saying it's a right-angled triangle because there's a 90 degrees here. Okay, there's a 90 degrees here. There's a 90 degrees, and it having a 90 degrees here, you know, you can see it properly if we were to draw a straight line going like that to say that it's a 90 degrees and it's a right angled triangle. So what does it mean when they talk of right angled triangle? They don't need you to use the sine rule, to use the cos rule to find the other side if needed. Okay, so now we are finding cos. What do we need in cos? Cos, we need the cos is here, right? We need the adjacent over the hypotenuse, right? Adjacent over hypotenuse. Now, do we have those values? Now, we are looking at CED. Now, we need the opposite of that, CEB, okay? So, it's this angle that we are looking at here, okay? Which is in the middle, okay? And then the opposite, the adjacent of this one is this one, that is usually the value of one of the sides. Usually it's not there. And the adjacent is this one. And the hypotenuse. Which one is going to be treated as the hypotenuse? Because the hypotenuse is the longest side, right? So which one are we going to treat as the hypotenuse in this case? Because
Is it not BE?
So now, how we are going to treat this? We are going to look at it in this case, and then we'll treat this one. We'll treat this one as the opposite, and then this one will be the what? The adjacent side, and the longest side will be the what? Will be the hypotenuse. But it's the one that we have to calculate because we've already seen that it's going to be the longest, right? You see? So this one, because of how we are seeing it, we can say it's going to be the adjacent side of this one, of which is not the case. So this one is going to be the adjacent in this case. I've just seen that. So it's the adjacent of this angle. So this one is the adjacent, and the opposite is going to be that one. This one is going to be the hypotenuse. So now let's calculate the value of this one using Pythagoras theorem. Okay. So using Pythagoras theorem, calculating that angle, the BE, okay, calculating BE, we need what? We need, since it's the longest side, we need the addition of the two squares. You get the point? The addition of the two squares. So 4 squared plus 3 squared. So that is 16 plus what? Plus 9, right? Which is going to give us what? I hope nobody is confused there. On Pythagoras theorem, I'm sure in case you don't know much about it, you can ask, I'll explain. But from this point, if you are okay with me doing this, 16 plus 9, is it not 25? It is, right? So the square root of this one will give us 5, right? So 5 centimeters is that one, okay? So that is 5 centimeters. So that one is 5 centimeters, okay? So now, coming to this, the adjacent is what? 3. The hypotenuse is 5, okay? So now, when we just add the negative to this one, 3 over 5 becomes the answer of CED, okay? The value of CED. Are you guys understanding what is happening here?
And
Because this is paper 1, you don't have to really find the actual angle. You just leave them in fractions like this, okay? So, because we first have to find cos what? Cos CEB. This one, so the negative of this, the value of that other one, the opposite one is just the negative one. So you can research more on that one and find out why, and you can use a calculator to have specific angles to deal with, and you find that it's true, okay? So first we found cos CEB, okay? Before, now the negative cos CEB is the same as is the same as cos what? CED. So now cos CED is just adding a negative to that number 3 over 5. Is it clear? Anyone with questions? Anyone with a question? You're welcome. There's no one with a question? Okay, we are going to the next question. All these are very interesting interesting questions, right? So someone to read the next question. The other person can read, whoever is there. Is it Helen? You can read. You can read, I'm just waiting. Who else is there? Because I want you guys to be interacting with me, because if you can't interact with me, this class cannot proceed. Let's go. I'm waiting. There's no one. You guys.
the curved surface area.
Yes.
The curved surface area of a cone with radius 4.3 centimeters, 4.2 centimeters is 138.6 centimeters cubic. I don't know if it's a square or a cubic. I can't see clearly. Find its I can't see clearly.
Find its slant height. Okay. So now, for us to find the slant height of a cone, we can use the formula for the curved surface area, since we've been given the value of the curved surface area here, right? So now, talking of area, you know that area, the measurements, like the unit is cubic centimeter, which means that it just needs two dimensions, okay? You use 2 dimensions to find the area. That's why it's cubic, or that's why it's squared, okay? So now, let's just calculate everything from here. The formula of the finding the, you know, a cone. You know how a cone looks like? A cone, it's something that looks like this, okay? And, you know, I'm just drawing it up here. I'm not good at drawing. So it looks like that, okay? So now, it has the radius here, and you've got the slant height that they are talking about. So the slant height, what they want us to find, and we've given the radius and the area. So if we just have the formula for finding the area of the curved surface area. Now the curved surface area, you know, the curved surface area is different from the total surface area. That is one thing you have to know. So which means that even the formulas, they must be different. You get the point. So the formula for finding the curved surface area, now let's denote it as CSA. In short, curved surface area is given by pi r L, right? That is the formula. And we have the pi. We've been told to find so we can just make this one the subject of the formula. We can just replace in there and replace the values, and we'll deal with it and the end, okay? Where in the formula, R stands for what? The radius, and L is the same slant height we are talking about. So now we need to rearrange the formula to solve for the slant height. So now rearranging the formula, we are going to find that we are going to come up with this L will be equal to the curved surface area, because here we are just going to divide by this, okay? R divide by that, okay? Divide by that, okay? So curved surface area over the pi r. That will be our formula for finding that, okay? Now, given that the curved surface area is 138.6, right? 138.6. And the radius is 4.2. Okay, we can now substitute these values into that formula. Right. So now, let's just continue it from there. So the curved surface area is 138. Now, you know, paper one, they even bring you things from up. Then over. Now, pi, we've been told to take pi 22/7 multiplied by 4.2. From there, you do your calculations. Okay? You can do your calculations. Yeah. It's easy. You do your calculations and you find the answer. This is the only part that is hard, because for you to multiply this one times that and then you divide it into that, you really spend a few minutes here. But for now, since we are running out of time, you can just use the calculator. But in your exam, you're supposed to do it. You can simply just type so that you give us the final answer. We are running out of time. Time is not with us. You understand? So I've added 30 minutes to the class. We'll end at 23:30. So that's the thing. So what is the final answer? The slant. Someone have allowed you to use a calculator for now, because but in the exam you really have to, what you have to do is, when you're multiplying this one and this one, because here you can convert, you can change this one to a fraction, okay? You change it to a fraction, and also this one you can change this other part like to a fraction, okay? You know how to change this one, right? So now when you change it will be a bit easier for you now, because if you change it to a fraction, you can have something, maybe something to cancel, or it will be possible for you to just multiply and find it in a fraction type, and then you can, you know, since it's division here, You can bring it the other side and say multiplication, and then you reciprocate, and just like that. Okay. But if you just take like 2 to 3 minutes, you can be done with this. Nobody is calculating. What is the answer there? What is the answer? You people, you know that time is moving. Because you're surprising me. You're not responding fast, so that we move.
The answer is 18. I can't manage to.
Come again?
18522.
We have found 10.5.
10.5. We've got two answers.
Yeah.
Which one is the answer? Which one is correct? At the other one found what? What did the other one find? I didn't get it properly.
10.5.
Okay. So there's 10.5 and what?
I calculated long. 10.5. I calculated long. 10.5.
Oh, it's 10.5?
Oh, it's 10.5.
So the answer we are agreeing that it's 10.5 centimeters, right? So don't just say 10.5. Okay. So in this one, let's see. Okay. Now is 16, we go to 17. I hope you guys be able to understand properly. You're not tired. In case you're tired, you tell me at no.
Me now, my battery is 1%. So
You don't have power in your area. Or maybe we end here. So we should have another session to finish up 19 from 17, 9 at 19. Because I was planning we should end on 19. What is your suggestion?
for me, my phone will switch off now because it is 1%. So I don't know.
Okay. For today, let's end here. We'll have the last session that will make sure we finish everything that is remaining. Okay?
Okay.
Yes. Okay, so Helen and Hannah, thank you for being here with me, and good night.